We're going to take a look at some tools that would typically be used for engine service procedures. So the inspection of the components on the engine and whether those components are serviceable or not. Serviceable being that they meet manufacturer's minimum or max or below maximum specification, and are they reusable at that particular time, and how much longevity are they going to have if they're put in close to their wear limit, or hopefully have lots of longevity by being at their minimum wear limit. So some of the tools that are used, and I'm going to try and cover quite a few of them in these videos, in these segments, to inspect various components. So for an example, we have engine bearings. And for the purpose of checking dimensions on engine bearings, we would use an outside micrometer. And outside micrometers, they have different configurations to them. This one happens to tell us that it's from 0. So when the anvil is closed, it will read nothing, up to 1 inch. And it's always going to be allocated on the tool what that dimensional value and the incremental values that it reads in. Some of them will read in thousandths of an inch, some will read in 10,000ths of an inch. And you may read from 0 to 5 10,000ths or from 0 to 9 10,000ths, and then of course the next one would be the next whole number into the thousandths of an inch. So depending on what you are inspecting will determine the type of tool that you're going to pick. So there are a bunch of different types of outside micrometers. Some make things a little easier than others. This one is a manual one with the manual scale on it that we would read and calculate. This one happens to have a digital face on it, and it also has a serial port on the back so that it can be connected remotely to a computer if a bunch of values are being recorded to create averages. So depending on the average dimensional wear of a component, we would use a tool like this so that it can be recorded and calculated. This one is more so for a manufacturing aspect as opposed to a typical service aspect that we would use a standard micrometer for. Now, the other type of micrometers that are used for checking, for example, engine bearings, like I had mentioned, is this one here, and a lot of times technicians select the wrong tool. If we use the standard face and standard anvil, the anvils are cut square. So if we take a look at this one happens to be a metric one, not that it matters, but it is a bearing micrometer. So the bearing micrometer has a rounded anvil face on it, or a barrel face on it, or convex face on it, so that it does not put damage on the face of the bearing. The straight anvil for the measurement portion, or part of the spindle here, is one that comes up against the back of the bearing, and I'll show you what that looks like when we install this onto the bearing. So when I'm going onto the bearing to figure out the dimensional size of the bearing, I bring it down to the bearing and then lock it, and then we can have a look at how that sits on the bearing. So that particular tool is specific to that job. It doesn't leave a mark on the bearing, very small little touch contact point, because it's a rounded face, and that minimizes the contact so that when the tool is being moved around on here for adjustment, that it doesn't mark the face of the bearing. Because these bearings are very expensive, the face is very soft on them, and we don't want to put any marks on them prior to installation, because that can cause premature failure and hot spotting in the bearing. So let's taking a look at outside micrometers. Other tools that we would use, for example, would be Vernier calipers. And our Vernier calipers, as per in other videos I've done here, they are used for measuring 3 different dimensions. Our outside dimension, so we would check an outside dimension like this. Inside dimension, where we would use the anvils for the inside, and we could go inside and measure inside a hole and then take the reading. The other one is the depth mic portion, which we would drop down onto something and then push the anvil down and determine how deep it's actually going into that particular bore. Great tool for checking, quick dimensional check of a liner protrusion. And then we would use a sled gauge, which I'm going to talk about here in a moment, to get a more precise measurement for that particular inspection. So different vernier calipers, of course, have different functions or different capacity. This one here actually has, again, still has the outside, the inside, and the depth portion, but it has a dial face on it for individuals that would like to read it on the dial face as that incremented value, which is in, this one happens to be in 0.05 millimeters. So this one is only particular to metric dimensions. They do make them with the dial face for doing imperial dimensions also. If you don't have the imperial and if everything's in metric, you can do the conversion to get the measurement that you're looking for. So, next one here in particular we're going to take a look at is the dial bore gauge, or pardon me, not the dial bore gauge, but a sled gauge. And the sled gauge needs to be assembled onto this anvil here. It gets put into place and then gets locked down with an Allen key. Doesn't have to be tight, too tight. Has to be tight enough that the gauge is not going to move. And then we would check our dimension on the deck, for example, liner protrusion. So the liner protrusion is how far the liner sticks up above the deck block, or the fire deck of the block. So to make sure that we have enough protrusion to hold that liner in position, we need to find out how high it is, and we need to check it based on parallelism or concentricity. And concentricity is the difference between two parallel planes. So is it sitting like this or like this or like this? And when we use this particular gauge, that will determine how the cylinder is sitting in the bore. So all we do is we would put this down on top of the deck and zero the face, and then lift the anvil up and then onto the liner protrusion. Vice versa, some people do it the opposite way. They put this onto the liner protrusion, zero the face, and then slide it off and then read the difference. When liner protrusion is being done, it's done in 4 particular points. So we would check it at 4 points around the top of the liner to determine the overall average, or to determine is there any sloping of the liner in different areas that would need another service procedure, which would be inclusive of cutting counter bores and then adding shims to compensate for the difference of the cut and to bring it back to the manufacturer's specification. So the next tool that is being used for on the deck is a straight edge. So these are machine cut straight edges, and I'm not sure exactly how precise they are. I know that the Kent Moore tools here, and this happens to be a longer one for checking a longer deck surface. And I think they fall within 1/10,000th of an inch, which is a very, very small variation over the length of that tool. And it's very important for that aspect simply because when we put this on the deck of the engine, we want to make sure that there is no variation on the deck plane. And how we would check that is using feeler gauges. Now, feeler gauges are a really good, important tool for technicians. And we have a various selection of the size. The tool itself will tell us exactly what the dimensional values are. And for example, we can take a look at this one here in particular, which is 20,000ths of an inch, or 0.51 millimeters. So we continue on. So on the deck surface, then we'd be looking, and one of the quickest and easiest ways to determine do we have any warpage on the deck or on the head is put a light on one side of it. And if we see an opening, if we see light in one particular area, that means we have a distortion on the deck. So then we would use are feeler gauges to determine how much of a warp is on that deck, and it has to fall within manufacturer specifications, or the deck needs to be planed, resurfaced, ground, or sanded to make sure that it's nice and flat to be able to allow the gasket to conform to very small variations in the deck surface of the block as well as the head, and that all has to fall within what the recommendation of the manufacturer is. So the straight edges and the feeler gauges are what's going to determine how well the deck is true compared to manufacturer spec. One of the next tools here we're going to take a look at is telescoping gauges. Sometimes they're called a snap gauge because when they are installed into a hole, and if you listen, they snap out to the dimensional size, and then the size gets checked. So if we take this tool out, then we would check the size of this with a outside micrometer to determine the reading. So if we need to know exactly how big this bore is in here compared to the bore or the dimensional size of the pin, and the manufacturer tells us that there is a running clearance in here of, let's say, 1 thou, then we need to know that we have that running clearance of 1 thou in the piston. So when we take this out, we can use our telescoping gauge or our snap gauge to read or to attain the value, take it out, and then we can read it. So when this is installed again, we squeeze the anvils in, and then we put it in place, and then we can read that measurement. So these are just a couple tools that we're looking at in these particular video segments.